The grade 6 students also worked with patterns similar to those we explored in grade 3. What's the pattern core for this pattern? Do we have enough information? If we reveal more of the pattern, does this alter your prediction? What about now? What columns make up the pattern core? What would the 64th column look like? And how many repetitions of the core would there be if we repeated it to the 64th column? What unit are you using to find the answer? Are you using the pattern core, the template, your knowledge of multiples of 4? The students had a few ways to solve this, which we'll see in this video. Sylvie said, I think the 64th column would look like column 4 because you just need to times 20 by 3 and that's 60 and go 4. Underlying this answer is Sylvie's understanding that the 20th column would be the same as the 4th column, and 3 full templates plus 4 more columns, or 1 pattern core, would be the 64th column. Adam stated it would be column 4 because 4 is a direct multiple of 64, and it would come around to be a full pattern core. This reasoning shows an integration of both the numeric relationships of the pattern and the visual aspects, since Adam justified his thinking both through stating a multiplication fact and an understanding that the 64th column would be the last column of a core. Mike then asked the students how many repetitions of the core would be included up to column 64. Again, explanations from the students demonstrated an integration of numeric and visual reasoning. Here's an example. You'll see this conversation in the video, but it's helpful to have a bit of an explanation before viewing because there is a lot of complex math thinking packed into this brief exchange. Jonah's explanation was grounded in multiplication facts. It would repeat 16 times because 10 times 4 is 40 and 6 times 4 is 24, and add them together, it's 64. This answer was challenged by another student, Sam. 60? You were thinking of 16 as 60, but there's one extra one, so 64, that would actually be 17. One extra what? One extra pattern core. No, it's not, because 5 times 4 equals 20, which would make it 60, so that's 15. Then you add one more, it would be 16 to make it 64. Oh yeah, okay. If you'd like to discuss this exchange before we unpack it, please pause the video now. Okay, let's unpack this. Sam argued 16 repeats of the core would only reach column 60, and so one more core would be needed to get to column 64. But implicit in Jonah's argument is the understanding that the 20-column template contains 5 repetitions of the 4-column core. He responded that 5 times 4 equals 20, meaning there will be 5 repetitions of the core in one 20-column template. So that's 15, meaning for 3 full templates there would be 15 pattern cores, and adding one more pattern core would add 4 columns to 60 to end at column 64. The fact that Sam so readily followed this reasoning illustrates how fluently he and others in the class can think about the relationship between different units. What was interesting was how students justified their predictions using both their knowledge of multiplication, that is, that 64 is a multiple of 4, and the structure of the pattern and its relation to the template. For example, describing the 64th column in terms of 3 completed 20-column templates, or 15 pattern cores, plus one more core.